So Jim, one thing that I get asked a lot, and I think you do too, is just about efficiency of wireless power. So I think people have this belief that wireless power is less efficient than wired. And I think we know there's some truth to that, but it's also maybe a little bit overblown and it's very situational. So let me just start with a real basic question. How does wireless charging compare from an efficiency perspective to wired or pin-based contact charging?
You can have systems for both wired and wireless that are over 90% efficient. So, a standard wired energy charging system end-to-end might be in the 96% range.
Yep.
You can see wireless charging systems that are in the 92% range.
Okay.
They're going to be comparable or similar. There's really not that much of a difference if they're done right. There could be variances, certainly, but in general, a couple of percent, they're going to be relatively close.
Okay, so how big of a deal is that couple of percent?
Sort of depends on the system that you're doing,
Okay.
but in general, for lower power systems, it really becomes less significant than higher power systems. When you start getting into the kilowatt range, you get more concerned about the amount of watts that you're losing,
Okay.
and that can be more significant. For lower power systems, especially something you just plug into your wall outlet, it's relatively inexpensive, and from a consumer standpoint, consumers have kind of voted that they don't really care.
Yeah, so I think what you're talking about is that at low power, you're really thinking about the environmental and energy generation question. So are we using more energy because it's wireless power? So are we burning more fossil fuel? Are we consuming more solar power, whatever that is? And when we're doing low power things, 10 watts, even 100 watts and below, the amount of, let's just even say it's 100 watts, right? And it's 2% less efficient. You're burning 2 watts more of energy in order to power that device than wired. And at the end of the day, that's not very big. I think you have some financial numbers on what that might actually mean to charge a phone, let's say, wired versus wireless. So how much would it cost a consumer to charge a phone wirelessly versus wired?
Yeah, I was just looking at like the recently announced iPhone 13 Pro Max. It's got a 4,300 milliamp hour battery. If you charge that every day, even with a very inefficient battery charger, you're on the order of a fraction of a penny per day per charge.
Okay.
Over the course of a month, you may be charging in the order of 60 cents or so. Relative to the average, I think, U.S. household has a $115 per month electricity bill.
Yep.
This is really small.
Yeah, we're talking about, in the 1/1000th or 1/10,000th.
You're talking in about 1/1000th of your energy efficiency is really our bill is based on that. I think the consumers voted that for something like that, they'd rather have the convenience than worrying about the energy losses or inefficiencies with power levels that small.
Yeah, because honestly, if we wanted to make the systems more expensive, using higher quality components, using higher efficiency components like gallium nitride FETs, for example, versus MOSFETs, we could drive to those efficiencies as well with wireless power. But the OEMs, the phone companies, and also the consumers are voting and saying, the extra 0.001 pennies per day that this costs to do wireless is not a big energy loss relative to adding another dollar or two to the phone when it comes to manufacturing it.
Exactly, and I think one thing to keep in mind is, if you look at the auto market, when somebody goes into the dealer to buy a new car, there's people that are looking at the Toyota Prius for efficiency or a Tesla. But many of them buy Ford F-150s for reasons other than energy efficiency, and they could be getting significantly lower gas mileage on it. And from a consumer standpoint, filling that vehicle up with gas is a heck of a lot more of their budget than worrying about wireless charging. And there, the consumers are kind of mixed on what their responses are. For charging a phone, wired or wirelessly, I think they voted pretty convincingly that they'd rather worry about the convenience than worry about the added fraction of a penny that it's going to cost due to any inefficiency.
Got it. Charging a vehicle, whether it's the super efficient EV or whether it's powering it with gasoline, it's multiple magnitudes more expensive from a energy consumption standpoint than the delta or the difference between wireless charging or wired charging of a consumer device. But let me ask you about higher power levels. So, usually the high water mark right now with wireless charging is in EVs. Whether it's, I think Momentum Dynamics is up in like the 50 kilowatt range. I know Witricity has some tens of kilowatts. I don't know exactly how high they go right now, but there's clearly a lot of power. And so using what we were talking about before, that once the baseline's up into the kilowatts, now every 1% of efficiency is another 100 watts or so of loss, right?
Yep.
So now it does become more of an issue of efficiency. Do you agree with that, or do you see it differently?
Totally agree with that, and not wasting that energy becomes more important. And the other thing is, how do you handle the energy that's wasted? You have to dissipate it somewhere. Dissipating 100 watts of energy is much more of an issue than 1 watt of energy or half a watt of energy. So it depends on the system itself, but when you go higher, then efficiency naturally becomes more of a concern. And so it makes more sense to use the better components to drive the efficiencies higher and higher.
Yep.
And even looking at the EV market, it's still in its infancy right now,
Sure.
and will continue to improve over time. And even so, they're within a few percent of where a wire charging system can be.
Yeah, it's really impressive actually what those companies have done at those high power levels, and with the large air gaps that they have to deal with between something on the ground of a garage or embedded in a road and what you can do up at, put the receiver in the undercarriage of the vehicle. So I'm really impressed with that.